Hi, everyone, and welcome to another K6 Office Hours. I am Nicole van der Hoeven, and as you can see, my normal co host, Sime Aronson, is still on vacation. So, first, I've got my other coworker, Danielle Gonzalez Lopez. He's actually been at K6 Office Hours twice previously, right, Danielle?
Yeah, that's right. Yeah. Hi, I'm Daniel. I'm a site reliability engineer at K6.io. Happy to be here.
And you want to tell people who don't know you yet what you do?
I try not to break things, right? But yeah, as I said, I work as a site reliability engineer at K6 and on my free time. Now, not on my free time, but I'm a maintainer of Grafana Tempo, a distributed tracing.
Yay.
Yeah.
And the
Yeah.
previous two office hours that he was in, he talked about observability and chaos engineering. So those were really interesting. And today we also have another special guest, Kelvin Zhang.
Hi, everyone. My name is Kelvin. I recently graduated from Imperial College London, and I suppose I'm here to present a bit of my master's thesis. And it's great to be here.
Awesome. Thank you for joining us. So what did you study actually?
So I studied computer science. It was a 4-year course and quite arduous, a bit arduous, but we got there
Yeah.
in the end. Um, and I think the focus for my 4th year was mainly on software engineering principles.
Hmm. So the reason that we wanted to get you on office hours is because we heard of this awesome master's thesis that you did. But can you tell us like why you sort of chose that topic and what it is about?
Sure. So I think the main reason goes back many years to when I learned about this. Basically, in the UK, you have these challenger banks, like Monzo, for example. I think you have N26 in Europe and Simple in the
Yeah.
US. And these are banks which revolutionize their infrastructure. So you don't have to deal with the inefficiencies of, let's say, Chase or JP Morgan with their slow infrastructure. And they released a blog post called Building a Modern Bank Backend. And that was my first foray into the world of microservices and distributed systems. And I had this passion going into university and this ambition to do some project to do with microservices. And by the time I reached my 4th year, when I had to do this individual project. Um, I reached out to a few academics within that area and ended up stumbling on this research area, which combined essentially microservices, Kubernetes, and control theory together.
Those are all concepts that I'd love to break down. Danielle,
Sure.
you want to talk about the because I know this is right in your wheelhouse. What's the difference between a monolith and microservices?
Well, the main difference is that you not only have one service, you have multiple ones doing different functions. This is something that the industry has experienced over the past few years as complexity has been growing up. Multiple teams working on a monolith is kind of complex sometimes. Yeah, these things started to split. Um, and tools like the one that Kelvin designs are pretty useful on that case, right? To manage all that complexity and handle those cases.
Yeah, I think the main advantage of a monolith is that it's difficult to tune because it's all deployed as one gigantic thing. And if you want to just tweak one of those components, it's harder to do. Whereas if it's microservices based, then everything is much more modular. So you can scale them individually if you need to, and there's a lot more room for tweaking. But there's also complexity in that, right?
Yeah.
Because there are many more things to tweak, many more knobs to turn.
And also the microservices have to be like decoupled, right? If you have like microservices that are like tightly coupled and you can't scale them or you can reuse them for other things, they're like there's no use, right? Of microservices, you are just adding layers of complexity without
Mm.
any real benefit. So yeah.
And then one thing I think to add is that the irony is that with microservices, you're trying to decouple tightly coupled parts of systems. So for example, if you have a database, a front end and a back end, you split that into a shopping microservice, an order microservice, a catalog microservice. But in the end, you always have tightly coupled areas like the connection between your single database and your other microservices. That will always be, for example, bottleneck.
Yeah. And I think that part of what you wanted to address, Kelvin, correct me if I'm wrong, but I think your thesis wanted to address the complexity, how to make it, how to be able to still make the whole application performant, and how to fail gracefully, I guess, in some occasions, because part of the reason, part of the concern with microservices is sometimes they can get into this weird feedback loop where it's just a retry storm, where there are
Yeah.
requests that are being sent back and forth between the microservices, that even if, and if one of them is down, those requests still continue, right?
Exactly, and I think one of the techniques to try, one of the traditional techniques to try come across this is the concept of a circuit breaker. So when you do have retry storm, you have this system which just shuts off and goes, no, you can't make any more requests. The disadvantage for this is that this can be very sudden, and this might ruin the user experience. The alternative is that when you do have retry storms, or when you do have periods of high load with microservices, um, the system can slow down a lot for users. We see this with monoliths too. When you're under high load, the server takes, 60 seconds to respond. And if you're Amazon, let's say, then you can have hundreds of thousands of users leaving in those 60 seconds. And we don't want that. We want a more graceful way to perhaps say, come back later because this website's under load.
We do have this comment from Sava Genchevsky. He says a monolith is easy to deploy but complicated for development and testing, and a microservice is easy to develop, but there's complexity for development and configuration. Would you both agree with that?
I think I would completely agree with that. Yeah.
Yeah.
Yeah. Good comment. I actually also just want to share something quickly, because I think it might be helpful for those who want to know more about the circuit breaker that Kelvin was talking about. So I like this diagram. I thought it was useful, so I thought I'd share it. So this is like the closed state of a circuit breaker. So it kind of acts like a middleman in between the client and the microservice, or I guess between microservices. So it gets I think of it as like a traffic controller. So it gets all of the requests and determines whether it should or can reroute to the correct microservice, and then it does the same with the response back. So when it's in the closed state, the requests just go through it and to the correct microservice, and then goes back, and the response goes back and is returned. But just like a real circuit breaker, in terms of the one that's actually in our homes, this is what it looks like when it's tripped. So instead of passing on these requests and then forwarding the response, it kind of says, stop. There's, this microservice is already down or experiencing high load or some other issue. So it, rather than bombard it with even more traffic it can't handle, let's just stop here and call it an error. Did I explain that okay?
Yeah, and I think this is a good explanation, and I think it's worth also pointing out that a circuit breaker is also very reactive. So circuit breakers come in when retry storms happen, when timeouts exceed a particular preset value. What I think prior work to do with the thesis has involved is trying to take a more reactive approach, or proactive approach, more like, i.e., we take this concept of a circuit breaker and we apply that before the application becomes fully overloaded. So you perhaps use this idea of control theory to proactively increase the level of circuit breaking, or I think, as prior work calls it, brownout, in proportion to the user load, in proportion to the system load.
Okay. Can you tell us what brownout is?
Yeah, so if you imagine the electricity grid, when it becomes overloaded, power companies tend to prioritize electricity to commercial applications, perhaps critical applications like hospitals and infrastructure, while residential homes lose that power. And that's called perhaps slightly misused for the electricians here, but I think that's what's called brownout in that field. And when applied to this area of software engineering, it's very much the same, except you're dealing with requests as opposed to electricity. So when requests come in, if your system's in a brownout state, that request will immediately be rejected based on some, I don't know, probability check or some other heuristical factor.
So would it be accurate to say that what you created, CubeDim, is an implementation of the circuit breaker pattern?
Yes, but I think there's a lot more going on in terms of figuring out which requests and to what extent we would end up circuit breaking.
Okay. So what is CubeDim?
That's a very good question. It's a big question. I think the nicest way to put it is that it's a reverse proxy, and I'll see if I can get up a nice sort of small diagram to illustrate this. Yeah. So
I can add. Yeah.
So if this is our Kubernetes cluster where you have your user request going into some number of pods, CubeDim is meant to be this very easily drop-inable solution, which acts as a reverse proxy with the added benefit that it can orchestrate brownout on your system with more or less minimal configuration. At the baseline level, it uses prior work in which it just uses a PID controller, so control theory, to brown out the application in proportion to user load. But the aim of this thesis has been to add more techniques, more advanced techniques, to decide how much brownout and how to do brownout in its orchestration.
I kind of like how you described it in the thesis, because I got strong chaos engineering vibes from it, because in chaos engineering, it's very different from testing in that testing tries to prevent failure, and chaos engineering is more like, look, failure is going to happen. Let's just see how we're going to deal with it. And I felt that when I was reading your paper, it seemed like you were doing the same thing with CubeDim. You're not trying to necessarily prevent failure. You're just assuming that at some point there will be errors, there will be load that the application cannot really handle. And then what do you do in that situation?
Yeah, so it definitely is sort of buying time for microservices platform. And the idea with CubeDim is that if a system saturates at 100 users, let's say, without CubeDim, with CubeDim, you can maybe have it saturate at 240 users. And that's already a big improvement, especially if your application is business focused, so maybe a shopping cart application where you're trying to make a profit or revenue.
So is dimming like a brownout? Are those two concepts the same?
So that's a good point. So if you've noticed in my thesis, I use brownout and dimming quite interchangeably. And I think that is a stylistic error on my part. I think they're meant to be seen interchangeably. Yeah.
Okay. So you think that there is a slight difference there?
No, I think I would say it's the same.
Oh, okay. All right. I see. Yeah, because I also wasn't sure. And I believe that that's where the name comes from, right? CubeDim?
Yeah. So Kubernetes and dimming.
So I think that all this terminology of brownout and circuit breaker and dimming, it's very much using ordinary language for describing something that is complex and very technological, but we're talking about it in terms of electrical currents and lights going out or lights going down, just because it's a lot easier to grasp that way.
Exactly. And I think the aim with this project was to build something or engineer something which could be used in the real world, or at least could be configured by an average developer who doesn't know much about control theory and who doesn't know much about performance engineering. And there's a big contrast between this project and a lot of prior work out there where you have Lots of instrumentation tooling like the Kika monitoring framework, for example, which sounds scary, which tries to gather data about a microservices platform. In contrast, KubeDim tries to assume the developer has minimal knowledge about control theory and about, let's say, circuit breaking or brownout, and tries to handle the heavy loading for them without actually making them feel uncomfortable about the system being a black box. So it tries to explain the concepts without explaining too much, essentially.
Which I think is more realistic, honestly, because I have never heard of it. It's a completely different way of approaching it. I haven't, just the concept of blocking requests, some requests on purpose so that others can go through. I mean, normally we're trying to prevent that from happening, right? We're here in effect, we're creating a bit of a bottleneck in some areas, which seems counterintuitive.
Yeah, so when you say a bit of a bottleneck, do you mean in terms of KubeDim does dim perhaps some endpoints more than others?
Yeah, so I just mean that normally we try not to throttle requests at all. We try not to do any dimming. That is the traditional approach. And so this approach of, well, if we know that we're going to need to make the choice, maybe let's make the choice preemptively and intelligently based on, previous experience rather than just trying to forge ahead and doing it anyway.
Yeah, so that's a big aim of KubeDim, and like I said before, when I was doing this with my supervisor, we tried to do this in a way where developers wouldn't feel scared, because if you have a system which drops requests in your overall system, it doesn't give you the full confidence that this is something which helps your system stay up. So it's a bit ironic that you're trying to make developers feel comfortable to add in a system or add in an application which drops their requests, right?
Yeah.
A bit related, but right now, most applications or some companies, right, deploy things on the cloud. How do you see KubeDim on that environment? Because usually when people think about, okay, my application can't handle 100 requests, we auto-scale it, right? Or we put things like that into place. So how do you think that both approaches compare? Maybe they can coexist, or how do you see that thing?
So I would say that KubeDim is quite orthogonal to autoscaling, or brownout as a field is quite orthogonal to autoscaling. I've seen prior work which tries to combine it and investigate it, which has been quite successful. But the downside of autoscaling, which sort of motivated KubeDim, was that there is a point where autoscaling won't work, i.e. When you run out of, let's say, the finances for more resources, or when you do have a bottleneck due to the coupling of your system. And we talked earlier about coupling in the context of microservices. And I said it was ironic because, let's say, you could have that one database, which would be the bottleneck. And in that situation where you've done your auto-scaling, but you can't replicate that non-replicable database, for example, that's when auto-scaling stops working and you need an orthogonal solution to try delay the downtime of your application.
So we can say that, for example, with KubeDim, even if you can't auto-scale merge applications, you can still give this good service or somewhat good service to most of your customers, right, during a bigger time frame than
exactly. And in terms of time frame, it's good that you mentioned the time axis too, because with auto-scaling, you do have that reactivity time. So you do have that time between your autoscaler detecting an influx of requests and your system scaling up. And that could be on the order of minutes, especially if you have, let's say, cold start times, if you're using particular cloud platforms. And in contrast, KubeDim, I think, does have a bit of reactivity required. So it does require maybe 20 seconds to react to load, but that is still faster than perhaps spinning up a new instance on the virtual machine, which has to start up from cold boot.
So let's talk about the different ways, the different experiments that you ran. The first one was like the baseline, which was uniform dimming. which I believe was just inducing dimming when the 95th percentile response time was greater than 3 seconds.
Yeah, so that's more close to the prior work done by students or researchers in the past years, where they've just placed their dimming system, their brownout system, in between the user and their reference application or backend. And they monitor the response time of the application or the CPU utilization of the system. And when that crosses a threshold, they dim all the web requests uniformly. Now, that is fine, but you do lose, I think, a bit of a number of users, or you do lose the benefit of having users still being able to check out of your system, for example. If you want to maximize the profit, then if you dim your application, you'd rather just dim users who are browsing as opposed to users who are buying from your reference application, from your shopping cart, for example. So that's why uniform dimming, although it works, is not the best solution.
But it is still better than no dimming at all.
Exactly. So with no dimming at all, if your system comes under load, I would say it just goes down. But it goes down in a really bad way, i.e., users end up waiting for that system to time out, or waiting for the web server to time out over, let's say, 120 seconds. Whereas with uniform dimming, the server just goes, you can't use this, please come again later.
Yeah, and that ties into human psychology as well. It's kind of like how if you have to wait for 5 seconds for something to respond, and you're looking at a completely blank screen, then you're going to see that as taking longer than the same thing for the same time, but there's like a little loading icon or a progress bar or something. At least you know that it's not going to work. You're not just sitting there waiting to see if it'll work.
Fail fast,
Exactly.
right?
And
Sorry, what did you say, Daniel?
sorry.
I mean, it's better to fail fast, right? I mean, that to be waiting for that timeout that might hit or might not.
Exactly, and that is where sort of using K6 came into sort of trying to model users accurately with those sort of with attrition and with think time, etc. That's why I think K6 was quite useful, trying to model that user psychology.
Yeah, I was actually just talking to someone about this last night. A future guest, Lee Barnes. We were talking about how there's a lot of focus in performance testing and load testing on the scripting part of it. But the reality is, just because you know how to do something doesn't mean that you got the what part down right. And I think that it's not often I think that the scripting part is probably the most straightforward part of a performance testing cycle, because things like the workload model and which transactions should you even script to begin with, or how much think time should you add, those are deciding on those many parameters is often more difficult than just writing the script once you know what you're doing.
Yeah, and I'm not sure if Daniel has anything to add about this because of his work in chaos engineering, but I think an added benefit of K6 is its configurability. You're able to use JavaScript or TypeScript to create your own to create your own sort of scheduler, or your own sort of scripts, or sort of load tests, to the extent of it being as advanced as you need it to. And that's what I did appreciate about the platform.
Also, I don't know if you know it, but we have like support for extensions. It's pretty recent. It has some months. Yeah, I completely agree with you. And for me, at least, it's one of the best things about K6, being able to build the tool that I need right now to do the job, right? Yeah, it's one of their biggest strengths.
And I like how you mentioned extensions, because I was looking into I think a Docker extension, and I didn't manage to play with it. But one of the difficulties with especially in academia, where you want reproducibility, one of the difficulties was trying to start from a clean state, testing state every single time. And you want that in industry too, of course. And with that Docker extension, I believe you should be able to restart Docker containers, which I think would be very useful if you wanted a clean slate every time you reran a test, or even in the middle of a test.
Yeah, for example, I have run some, not with the Docker extension, but with the Kubernetes one. I have run some chaos engineering scenarios where you first check that the system is deployed as you want, or you deployed it at the start, run the test, then remove it right at the end. So you can assure this reproducibility, as you say, and that can be pretty fancy. Yeah.
Exactly.
Yeah, I don't know if you knew that we actually have an extension, XK6 Chaos. Simon Aronson, who is the normal co-host for this, he actually created it, and it lets you do chaos experiments in the same script as your load testing script. So you can be randomly killing Kubernetes pods. It's pretty awesome. Danielle has written a bunch of things too, so you can also do CPU and memory starvation.
Yeah, but one warning for the users watching this streaming, you can destroy your infra with K6 without extensions. So be quiet with the load, right? You can
Yeah,
destroy
that's
everything.
true. Oh, I just love it. Just having that at my fingertips and just seeing those pods disappear. I'm like, let's add another user. The ultimate chaos monkey. But anyway, back to dimming. So there's no dimming, which is what everybody does, I think. The next level up would be uniform dimming, which is after a certain threshold that you set, whether that's based on response time or CPU utilization or whatever, requests then error out immediately or very quickly rather than waiting for them to be processed or attempted to be processed and then timing out. And
Yeah.
then what you went a step further with CubeDim, right? With non-uniform dimming.
Yeah, and I think non-uniform dimming is a term I just used to encompass the various techniques I experimented with the thesis. And the goal of this thesis was basically to um, uh, find out different ways to dim separate endpoints. So I would say non-uniformly, as in unevenly, so that we could get perhaps business benefits such as dimming the checkout stage less so that
Mm-hmm.
in progress checkout flows complete, therefore the business gains money, for example. And I ended up with two fairly conclusive techniques. And the first one was um, trying to figure out the exact probabilities by which we should dim each endpoint. So trying to find out weightings for each endpoint, the extent of each, the extent of with, the extent of which each should be dimmed, and the second being profiling. So trying to profile users to find out whether they're, let's say, buying from a shopping cart application or just browsing the catalog, or just, I don't know, reading the FAQs, and trying to dim based on their assigned profile. So those two orthogonal techniques are the techniques I tested, and then I evaluated them using K6 to come to my conclusions for the thesis.
So with the component weighting, is it like if let's say that you have an application component that does 60, that contributes 60% of the load, and then another one that does 40% of the load, how does that affect the dimming?
So I feel like there's actually a gotcha there. And the reason why this wasn't as trivial as, let's say, dimming 60% of the system by focusing on the component which contributes 60% of the load, is that when you sort of unevenly dim components, let's say you dim an optional component on the homepage, let's say the advertising system by 70%, and then you dim another optional component of your system by 20%. Now, you might think that if the advertising system contributes a lot of the load, then your system would be faster or more resilient in the end. But when you dim components, when you make components more unavailable, user behavior changes. You have to keep that in mind. So if user behavior changes because the advertising system is unavailable, then they might end up introducing load elsewhere. And that's just the temporal axis of a user behaving. You also have the sort of static axis of, if you imagine the call graph of a request. If your component is being used less, you might end up just shifting the bottleneck. Let's say if the database is under load, you might just end up transferring the database bottleneck to another component. So that's what the issue was with component weightings. That's what the real meaty part of the thesis was in trying to overcome.
Okay, so let's say that there's an application and one transaction is checking out, and another one might be just browsing product pages. So the did I understand it right that the complexity is that if you just say, well, the optional one, the browsing product pages, can be dimmed more, if you do that, then that means that the checking out that there will be that the checkout transaction is going to comprise a larger amount, a larger percentage of the total traffic, which might still end up being worse.
Yeah, so it's very unexpected in that way, and this is something which I think a lot of research within performance engineering or resilience engineering tries to overcome. I.e., what past researchers have done is that they've tried to white box model their entire system using complicated academic techniques to try identify the bottlenecks and try to come up with, let's say, an equation, doing some maths, which tries to overcome these, weird imbalances and bottleneck transfers and side effects. And these side effects are quite implicit, so you never know if you have a sort of an uneven request mix. You never know what bottleneck might come get you, and that's pretty much what this sort of part of my sort of thesis tried to address, and that's where K6 did come in.
So I guess it's like a delicate balance, right? Because you want to do some dimming, but not
Yeah.
enough that it swings the pendulum all the way in the other direction.
Yeah, exactly. So I think the goal is let's do some dimming and dim our optional components unevenly so that we try maximize our business objectives, but we balance that with trying not to just shift the bottleneck. So we want to achieve our business goal without actually ending up making the system even slower.
Danielle, do you know, have you heard of dimming being used in a corporate setting?
I have seen like the circuit breaker pattern that is more or less the same from what I understand, less intelligent but more or less the same. There is this project from Netflix called Xtrix, if I remember well. It was some kind of a state of the art around this. Also,
Sorry,
people
what
right
is it
now,
called?
Xtrix, uh, I think. Yeah,
Like asterisk? Asterisk.
Okay. Hystrix, is it Netflix you're talking about?
yeah, this one.
Yeah.
Asterisk, okay.
Yeah, also right now for example, with proxies, right? Or with people using service meshes, you can also implement these things right outside of your application, so you don't have to change the code and things like that. But actually, I was thinking about one thing when Kelvin was explaining that. I think this pairs very well with observability engineering and having this indicator that give us and these objectives where we have to accomplish these goals, right? For this service to be in a well state, right? And to understand this. I have one question related with that. How do you think that this tool can be paired with, for example, with knowing those service level indicators, service level objectives? Maybe instead of priorities per service, maybe we can prioritize this dimming based on the availability for a given month for some service. Let's say that maybe this service has failed a lot during the first half of the month. Maybe this one can fail a little bit more today, right? Just to
Okay.
try to, yeah. So
I don't think KubeDim has addressed that part of SLOs just yet. The sort of focus of the SLA part of the thesis was into looking at response time SLAs. So just to sort of clarify the question, do you mean SLAs in terms of, or do you mean trying to dim in terms of focusing on SLAs as a business objective, i.e. trying to keep up the systems which have more strict SLAs?
So, for example, let's say that I have this agreement with some company and I have to
Yeah.
pay them some money if, I don't know, if less than 99% of requests fail or something like that, right?
Right.
So maybe being able to redirect this failing request to a service that has more bandwidth to fail during the rest of the month, right? Instead of because maybe this service is not that important, but if we fail on that service, even if it's not that important, we have to pay to the client. So,
Right.
yeah.
So
That's really interesting.
would it be redirection then? So if a request comes in and the service is under load, you just end up redirecting it to another service. Is that what you mean?
No, I mean, let's say that you have this order flow, this order service,
Yeah.
right? And this order flow has a very low priority, but has failed a lot during this month, like a lot.
Right.
We're almost going to hit the agreement, right? And on the other hand, we have this critical flow, this critical thing that has been pretty good for the rest of the month, right? So maybe on that case, it's interesting to deem based on that, right? Because for our business, it's more important to have this maybe this principal flow failing, but we don't have to pay all this money to some company, right? Yeah, just trying to mix concepts.
That is a really interesting concept because I think that links in a bit with user profiling, i.e., if you have a user who's been sort of detected to be on the checkout flow, we'd want to usually prioritize that over users who are doing the sort of FAQ or just browsing flow. And I suppose with Kubedim, you could sort of gel that together with your concept, where if the SLA of a low priority system is being reached, you just tweak the very simple configuration values to dim the sort of important service a bit less and dim the less important service a bit more. That is a bit still manual because you just have to change that configuration, that config map value. But I suppose it wouldn't take extra work to integrate something SLA based into Kubedim either.
Yeah, being able maybe to track some metric, right? Some query for an indicator and being able to understand how it's performing over time and if we are going to hit it or not, and things like that. Yeah, so sorry for the off topic, but
no. I think that's actually a really good suggestion for a way to extend it. I guess one way that you could implement it is introduce some sort of dynamic weighting system so that you're not just setting it in your deployment file once and then that's it. Have it be something that checks continuously and adjusts the weighting depending on on its adherence, on a component's adherence to the SLAs, right?
Yeah, something on that line.
That's really a really cool idea. But I think that uneven or non-uniform dimming in general makes a lot of sense because not all traffic is the same, not for the servers and also not for the users. So I think like you're talking about component weightings in terms of traffic, but you could also do component weightings based on user perception. Like the homepage being down while maybe that's not, it's at the beginning, it's at the widest part of the funnel of conversions, right? So normally you would think, well, that's not very useful, but that might have a greater part to play in the user's perception of performance than like the readme or the about page or something like that.
Yeah, and with Kubedim's configuration, that's why Kubedim doesn't automatically dim all the pages automatically. You actually specify exactly which components you want to be dimmed or which API endpoints or HTML endpoints you want to be dimmed. And it's also worth saying, usually, I think the pattern so far in sort of this academic field has been the dimming of optional components. So if you have your recommender service or your advertising service or a random icon in the top right corner of your page, which somehow takes up a lot of load, maybe like your cart indicator, if you have 4 items in your cart, that icon could take up a lot of load with your database and your cart microservice, then those would be the candidates for dimming, leaving your perhaps HTML homepage, which is static, untouched and always up.
Also, I think that it's good that we focus on the microservices thing here because that's like the main focus of the tool, right? But still, I also see a lot of benefit on having this in front of a monolith, right? Because on a monolith, different paths can affect differently that application, right? And it's a wall, right? So it's going to affect the rest. So I think that putting Kubernetes in front of a monolith is also can be a really good benefit, right?
Yeah, and I think there's always this misconception, which I fall into a lot, where if you think Kubernetes, you think microservices, but you can very feasibly stick a single SQL database, a single front end server, or your HTML files, and your PHP or Laravel platform, let's say, on a Kubernetes cluster of running just on one node, and that's a monolith right there.
And you get the benefits of
Exactly.
auto scaling and deployment and all those things.
I think you might be muted, Nicole.
Yeah.
Oh, I was. Thank you. All this fancy technology. Now I can hardware mute myself and it can double the chances of me talking while I'm muted.
It was a
Okay.
cool moment. It was a cool
Yeah. So I was saying that I think we've definitely seen the shift from monoliths into like towards microservices, but I've started to see some of the shift back as well for things that we already mentioned, like because of the complexity that's involved here. So, we don't know right now. Microservices are the in thing, but there's nothing new in testing. Everything comes back around.
I actually have an interesting, I wouldn't say it's an anecdote. Basically, Monzo does these engineering blog posts. And Monzo, if you haven't heard of it, it's this one of those challenger banks in the UK, I think one of the leading ones. And they have this engineering blog where one of their posts is on how they implemented this faster payment service, which is one of the ways to send payments electronically between UK banks. And they actually, despite having a microservices-based architecture, they had a small monolith responsible for transferring those files to the external faster payments service. And that's simply because it assured them with replayability and reliability among the sort of slightly more unreliable and prone to failure microservices architecture they had.
That is interesting for them to intentionally choose a monolith. So you already mentioned another way that KubeDim can also apply non-uniform dimming, which was user profiling. What does that entail?
Yeah, so the technique I chose, especially given the time limitations, I think of a 9-month long project around your exams and modules, was to simply log the pages a user has visited and apply some very easy rules-based heuristics configurable using config map to sort of detect which profile a user belongs to. So it's not the most privacy enhanced solution to say the least, but I think for the purpose of experimentation with what would happen if you profiled users, I think it was quite interesting to see the results. And with this pipeline, which involved I think Redis and InfluxDB and the main Kubernetes server, I think we were able to profile users quickly and then orchestrate dimming by weighing sort of different profiles differently, and that ended up allowing users who, let's say, were buying from our shopping cart application to complete the flows more consistently. And it's also the case that when you have this profile-based approach, the user's experience is more consistent. Because if you think about dimming components arbitrarily, if you're the user browsing a web page, if you're browsing a few pages, you might see optional components dropping in and out because of the dimming. But if you dim a profile user entirely, they're either completely dimmed or not dimmed at all, which means better user experience.
So, go on, Danielle.
Okay. But I was thinking that if you have those profiles, I don't know if you can do this right now, but I suppose you can also kind of prioritize some type of users, because maybe you have some users that are more important than other ones, because maybe ones are using the free tier of your application, and even if failing it's not good, right? That's better than failing for the one that is paid. So there is something like that, or what are your thoughts on that?
So could you repeat what you meant by profiling based on that?
Yeah, so you said that it's better to have like this user perspective, right, and not failing for I mean having this perspective of a full
Yeah.
interaction of an user with different endpoints and things like that. So I thought that once we identify like users having some kind of flows with different endpoints, maybe we can prioritize based on what type of user it is, right?
Yeah,
Yes.
so that is, I think, the core aim of this technique, i.e., you'd be prioritizing users who would be checking out of your system over users who would just be browsing without intention of buying, let's say, things from your shop. And yeah, I think that's the core principle. I think the way you actually profiled the users is wasn't the focus for this. I think the focus for this technique was seeing what would happen if you dimmed um, endpoints for users consistently, i.e., if you're user A and you're dimmed, all your components are dimmed. If you're user B and you're not dimmed, then everything's
Mm.
available. So that leads to much more consistent, less intermittent user experience.
But I think that the approach that you were talking about in the paper dims depending on what they're doing, right? And I believe that Danielle is suggesting dimming based on the intrinsic importance or value that the user is has to the business. So meaning if they're on your free tier, even if they're checking out, well, then maybe you can dim them. But
Yeah.
if they're one of your biggest customers, then never dim them.
So I think that would be achievable through. It wouldn't be first class supported now, but I suppose you could do this by simply setting a cookie for the priority of a user at the application layer. So if your application knows this user is important, or they have a strict SLA, then you can simply assign a cookie to them which says high priority or low priority appropriately.
I would love to see some users changing the cookie on the top.
That is a thought I had when I was doing the project.
Yeah, yeah.
Yeah.
Now that I know what to look for.
Yeah. So to say the least, I think academic applications aren't the most secure, but I think that this is where HMAC and JWTs would come in, and then it would become a very fun engineering task.
Well, so Danielle, did you actually get to? I didn't watch the video, so I don't know. I'm sure he gets to it, but do you know which one did better, like in terms of the uniform dimming and then the two uneven ones? Because I thought it was a bit surprising.
I think the best one, or at least the one that I liked the most, was the one based on priorities, right? Based on weights. But being honest, I don't remember the exact results, so sorry.
So I'll help you
Well,
out here, Daniel. And so
do,
it was the one with component weightings in the end.
Okay,
yeah.
that's
So
good. Yeah.
I actually have numbers here. There was first in general, there was a 22% improvement in availability compared to, I guess, not doing anything. But in terms of the three baseline dimming, component weighting, and profiling, the baseline dimming enabled, so baseline dimming disabled, which is just the normal, the
Yeah.
status quo, the response time was 5.25 seconds. And then with baseline dimming enabled, it was 2.997 seconds,
And by the
97
way, for the
seconds.
viewers, baseline dimming is the same as uniform dimming in this case. We just call
Oh,
it
yeah,
baseline
sorry.
because
Yeah.
it's aligned to the prior work. So prior work did uniform dimming. So we use that as a baseline for main experimentation.
Good call. And then the component weighting, which is what Danielle liked, it was, I mean, it's probably not significantly slower. It's 2.99 seconds, but it changed because of the nature of it. It changed how many people were able to check out, how many items were checked out, which was a significant improvement. So that's kind of interesting. The thought that you might have the same number of users and the same response time, pretty much, but it's still providing a way better experience, and you're basically getting more conversions because that's really what we're measuring with the checkout. But I actually was hoping for either the user profiling on its own or the combined one, where you combine the component weighting and user profiling. I was sure that would do so much better, but it didn't.
Nice.
Why?
So I think I think there's a few reasons behind this. The first one I think with profiling is that there is some delay when you have to profile users, and because I think this experiment was more focused on what would happen if we kept components available or unavailable for users consistently based on their cookie assignment. The result of that was that we had quite a lot of users with who were high priority. So in the end, they would be hitting all of the all of the bottlenecked or high load components. Whereas for component weightings, you sort of consistently identify which components contribute a lot of load to the system, and then you dim them for all the users. So despite profiling, I think being perhaps the best for the business case, or you'd expect it to be the best for the business case, when you dim the components which contribute the most load, regardless of the user profile, that's when you have the biggest effect. And I think in terms of future work, if we use different profiling methods, then I suspect we would begin to see much better results. Yeah.
I was also wondering, and I know that we're just speculating here. Sometimes things happen and we don't really know why, right? Especially with a relatively small sample, because this was against one really demo microservices application, right? So there is that we could extend this by increasing the sample size and doing live applications. But I was also thinking that maybe with the component weighting, there was more rigor around choosing the weightings, because CubeDim came with an offline and online tool that gradually would try to suggest weightings, appropriate weightings based on what was actually happening. But then when it came to the user profiling, it was pretty much left up to developers to decide that. And that is really difficult.
Yeah. So it was a case of trying to instill confidence in developers that our system's making the right decisions with letting them be hands-on without confusing them. With component weightings, you mentioned offline training and online training, and what offline training is that CubeDim plugs into external tooling, external load testing platforms like K6, and it runs a small load test with a random assignment of component weightings. So maybe a 0.7 for the advertising microservice, and maybe the cart icon on the top right corner of your page, it dims it a bit less, maybe 0.1. And it generates this random assignment. It gets K6 to run a short load test. It gets the response time results and repeats perhaps a few hundred, maybe a few thousand times and then feeds the results through this some maths. So linear regression formula, some maths. And then you get your optimal component weightings. And then likewise with online training, where you're doing a bit of A/B testing here with randomly allocated component weightings. So in the end, it would improve the offline training weightings too. Of course, with profiling, we didn't have that rigor, like you said. It's more a case of developers specifying their profiling rules, and then the system dims accordingly. So you could say that the solution involving K6 is the one which was better.
Well, we always
with
hear
fancy
that.
math, right?
So why did you use K6?
Oh, so there's quite a few reasons here. And to give some background, I did a course which involved writing a small load testing script on the same shopping cart reference application called SockShop last year. And we used Locust for this. And Locust is this load testing scripting tool based in Python. And it's fairly self-contained. It's fairly simple and small to get. It's fairly simple to get up and running. But the issue was that it had quite poor configurability, and in terms of developer experience, it wasn't great because so some magic context, we needed to write user behavior diagrams or state transition diagrams, and the user would transition to different pages probabilistically. And trying to do that with Locust, we needed to use Python annotations, and everything was a bit implicit in behavior, and the developer experience wasn't great. If I drop in my a graphic from a thesis into my screen, this is one of the examples of the user behavior graph. So we wanted, especially given this was academic work, we wanted reproducibility, and we wanted users to be well simulated. So we wanted think time, we wanted user attrition to be modeled, and we wanted users who, let's say, were buying from this shopping cart application to have fairly realistic behavior, attrition, and perhaps a probability of adding an item to a cart. So you have this fairly complicated diagram. And if I did this in Locust, potentially I would lose my mind, just because the developer experience, I think, was quite key, especially when working to tight deadlines. I would say, in contrast, K6 is really configurable. So you have JavaScript or TypeScript support, and I went the TypeScript route because I sort of enjoy having that linting. I enjoy having that sort of extra type safety. And I ended up implementing a fairly complex state transition diagram simulator, or the scheduler, which handled attrition, which handled user behavior models. But what was particularly useful once that sort of modeling, once those TypeScript files were written, was that I could then pop over to the K6 Cloud. I could add in the tags I wanted to collect. So let's say the number of items checked out would be a tag. And then I can view those results on the K6 Cloud to reassure myself that I've written all the code correctly and everything works and everything behaves as expected. So this entire ecosystem, which was well documented, which could be configurable, where I had the power as a developer to write the scripting code with high confidence, plus the GUI, I think this was really important to me. And that's why I chose K6.
Oh, that's so nice to hear. But don't let it be all about, singing our praises. Were there things that you wish that K6 had been able to do, or were there features that you wish were there? I mean, I guess you wish that that you hadn't needed to write the scheduler, right? That sounds like a cool thing that could be an extension.
Yeah, so I did the scheduler by first starting from the boilerplate repo, which was on GitHub. It did take a bit of time to write, but it was quite satisfying in the end. That could be one example. I think the main thing was that K6, or perhaps I just want to sing some praise quickly first, because just one thing popped to my mind, and the one thing is that K6, despite not being widely used in academia just yet, it has support for, let's say, closed and open arrival models. And the arrival modes which K6 has is really applicable to academia, where some tests, some scenarios, you want a closed arrival model, where VUs, virtual users, don't come back to the pool until they finish their scenario, they finish executing the scenario, versus open arrival models where VUs get executed at your chosen interval, and that's really useful for academia. But to answer your question about improvements, I think in terms of developer experience, having that async await syntax was something I did miss. So if you, for example, the group API, the group function call, which is this anonymous function where you can group your other K6 function calls, despite that being an anonymous function, where in every other world you'd assume that would run asynchronously, the K6 engine actually runs that code synchronously, so that when I was sort of trying to work with variables around that anonymous function or that callback, my IDE, my linter would complain that I was using, let's say, use before assignment. Right, so we had a few linter errors because of perhaps the lack of async await. And I know that I think global JavaScript event loops are sort of in the pipeline, or have been talked about a lot on the K6 forum.
I think it's related with Goya, the interpreter that K6 uses with JavaScript. So once event loop, I think, I don't know, it's implemented. I think we can start adding async things, I think.
Gotcha, and that's great, because when you have that, then you don't have, I think, any more sort of implicit behavior to do with the way your code is written. And that's a big contrast to, let's say, other load testing platforms where there's a lot of implicit behavior when you write your scripts, right? So that was the only gripe from my end. I think the sort of implicit behavior that despite having anonymous functions, APIs with anonymous functions, your code would still run synchronously one by one.
That makes sense. We do have one final question from Naveen Kumar. Can we integrate KubeDim with Rancher?
Would you mind explaining what Rancher is? I've heard of it, but I don't think I've used it before. I haven't used it before.
Rancher is a tool for deploying Kubernetes clusters. I mean, it handles the operation of nodes. It gives you this UI, right? This great experience. I see it more
Okay.
like a Kubernetes distribution.
That's something I would have to look into. But what I do know about KubeDim is that it's written so that if you weren't using Rancher, if you were using a bare bones Kubernetes platform, you'd just be able to write KubeDim apply -f and then kubectl apply -f, then the KubeDim configuration file. So given that it's been made to be easy to apply, let's say uniform dimming, for example, the very basic dimming method, maybe applying it with Rancher or integrating it with Rancher shouldn't require too many extra steps.
I'm going to try it. Not with Rancher, but just in general. I'm going to play around with KubeDim. Danielle is laughing because he knows I'm going to be going to him if anything goes wrong. Like I know what to do when I'm reaching outside of my comfort zone.
Next week will be Nicole trying circuit breakers and It's okay, Nicole.
I'm always learning things in public, apparently. Before we wrap up, is there anything that you want to plug or anything that you want to say?
I just want to give a big thanks to the K6 team and everyone on the forums who helped me out. I think having an active community, the K6 community, was really invaluable during this time. So thanks to all the contributors and the K6 team. But I also want to thank my supervisor, Antonio Filieri, who helped me a lot with the control theory side, especially, and who helped guide me through this project. And that was especially helpful, I think, during especially the last year in the pandemic. So a big thank you to all of you, and I suppose that's my plug.
Thank you so much. That's, if you were on the community forums, that's almost entirely handled by our developers, actually. So
Awesome.
it's a good job on their part too. But thank you for coming on. It's been a few months since we first started talking. I'm definitely going to reach out to you when I try all this stuff. But I think that it was great. The thesis was very, for me, novel in its approach.
Oh, I appreciate it. It's good fun working with K6 too. I really enjoyed working this platform.
Also, for anyone that wants to try Kelvin project, it's pretty easy to set up, at least from what I see on the logs, what I saw this morning. So yeah, give it a look.
Awesome.
Yeah, KubeDim. All right. Thank you, everybody, for watching, and we'll see you next week. Have a good weekend.
Bye-bye.
See ya.